What the? Do you hear that bird? Is there a bird in here? What the? Oh no, it's just Newbold making bird sounds. What? Thanks for watching. So 7.5 is where we're at here. So 7.5 is doing word application problems, which is exciting. What the? Floor's dirty. Where's the guy vacuuming here? What the? It's okay. Okay, oh, number 1. Do you have a condense and solve? Do you remember? Condense and solve. So we have 2 logs that need to, oh, pause me. What are you doing? You're just going to watch? You got to try it on your own first. I'm waiting. Condense it. Go ahead. Condense them into 1. What does subtraction become? And then how do you get rid of the log 3 on both sides? Do you remember? So we're going to condense it. Log base 3. X minus 4 becomes x over 4. Right? Yeah. Equals log base 3, 12. Josh Groban, how do we get rid of the log base 3 on both sides? How do we do it, Josh? What'd you say? I raise you up on the mountains, raise you more than you can be. That's right. You raise the logarithm up. And so how you do that is you go ahead and take a 3 and put it underneath it and raise that whole thing into the exponential position. And take a 3 and raise you up, stand on mountains, and raise you up, stormy sea. Okay, so there we go. So now the log base 3 goes away on both sides. We're left with x over 4 equals 12. We need to solve for x. So we're going to times by 4 to the other side. And so we get 48. Whoa, we get 48. I'm just going to double check and grab my answer key, make sure we're doing this right. Woo, and I'm back. Yep, 48 was right. Let's go, Newbold. Let's go, let's go. I mean, you can plug it in and double check, right? Wayo. Because 48 divided by 4 is 12. Okay, so try number 2 on your own. Try number 2 on your own. Leave an exact form. Find the exact value of the logarithm without using a calculator. Interesting, interesting. I like number 3. Well, let's see. Can you condense it? So ln is just log base c, log base c. And so log base c does cancel each other out, but first condense it. Okay, so we have 1 ln, and we have e to the 3rd power. And then what does subtraction become? What does subtraction become? Do you remember? Say it. It's division. Are we still recording? Okay, just making sure. Okay, division. So that's ln of e3 to the 3rd power minus becomes divide, e to the 7th power. And remember, it condenses from 1 ln, or 2 ln's down to 1. Condense it. Nice, nice. Okay, can we reduce that then? Let's reduce that. Well, we have 3 2.71828s on top, and 7 on the bottom. 1, 2, 3, 4, 5, 6, 7. So 1 for 1, 1 for 1. So we just have an invisible 1 on top. Good. So we're left with ln of 1 over e to the 4th power on the bottom. But we could change that, couldn't we? Yeah, we could raise it up and make it negative. So now we have ln of e to the negative 4 power, because I'm going to raise you up and make you negative. I raise you up. Now, do you remember that ln is the same as log base e? And log base e undoes base e. So we're just left with negative 4 as our answer. Woo! Just left with negative 4 as our answer. Ooh, maybe I should put that on canvas. I like that one. Okay, let's see here. Maps the function with its graph. Try to do them without the calculator. Yes, certainly. Okay, well, let's see. So number 6 has a plus 6 on the other side, which is the same as on the left as it is on the right. And what does that mean? Well, that means up 6. And then this is right 2. No, it's left 2. Left 2. So which graph is up 6 and left 2? Left 2. It's a logarithm as well. It's a logarithm. So up 6, left 2. Ooh, I think I see it. Let's take a look at the odd one. So the odd one is 6 times e to the negative x over 4. So we could do an xy table for number 5, right? Let's see. So let's try, what would make that x into, it's a fourth right now. So why don't we make x into 4? And then that would be 6 times e to the negative 4 over 4. Which 4 over 4 is just a 1. So 6e to the negative 1. So that's 6 over e. And so 6 divided by 2.781828 is approximately, 6 divided by 3 is just 2. So a little bit bigger than 2, between 2 and 3 basically. Right? You can use your basic calculator for that at least. So 6 divided by 2.718. Yeah. So 2.207 is what we're looking at. So over 4 up 2.207. So which one has a point at over 4 and up 2.027?
Hey.
Hey.
Is it alright if I vacuum in here?
Actually, can you come back in about 5-10 minutes? I'll be done with this video.
Yeah.
Hey, thanks for your help.
Yeah, no problem.
If you could do here too, it got kind of dirty here.
Huh?
And if you do right here too, it got a little dirty
Yeah,
here.
I'll do that.
Thank you.
Yeah.
Okay, let's see here. So then, let's see. Oh yeah. So we're going over 4, 1, 2, 3, 4, and up 2. That's not 2, that's way up there. Oh, this one. Over 1, 2, 3, 4, up 2 and a bit. So that's over 4, 1, 2, 3, 4, up 1. What was it? 2.27? That's a little bit too high. I don't even think that matches. Uh-oh, a little worried now. Let's try this one. Okay, this one's over 2, up 2 and a bit. Oh yeah, I can see it right there. That looks about right. What do you think? What do you think? Well, let's see. What's the y-intercept? Well, let's see here. Let's see. So I think we could try one more value there with our xy table. Let's try 0. What if x equals 0? That's always a good thing. So you get 6e to the negative 0 over 4. And 0 divided by 4 is just 0. Times the negative is just 0. So what's 6e to the 0? That's 6 times 1, which is 6. So over 0 up 6 is definitely this guy. We found it. Woo! Yep, so number 5 is A. Number 5 is A. Cool. So number 7 is just a log that's shifted. Is it up or right 1 or left 1? It's just a log. It's just a log that's shifted. Oh, it's an ln. It's just not just any log. It's ln. And so that's actually going to be, let's see here. So we want to reverse that. And so this is y equals ln of x. I'm gonna base e both sides. And so that goes away. So we're left with x equals e to the y power. Nice. And so since our base is going to be e, we are looking for e power there. And so when y equals -1, 0, and 1, x equals, what does x equal? X equals e to the -1, which is 1 over e. This one's going to be e to the 0, which is just a 1. And this one will be e to the 1, which is just e. And so, yeah, see if we can find that. So we're looking for over 1 up 0. Over 1 up 0. Uh-oh. Oh, but we shifted to the right one. Interesting. No, left one, left one. So this means left 1. So the parent function was here at over 1 up 0. I'm at over 2.781828. So that's over 2 up 1. Good. And then also at negative about a third down 1. Good. But the trick is that our graph shifted to the left one, to the left one. Good review, guys, good review. So this means left, this means left, this means left one. Remember, opposite, left one. So we're going to take our graph now, and we're going to shift it to the left one. Boom. Yeah, 7 is D. So our answer to number 7 is definitely D. Nice, nice. Okay, let's see. Now we get to the word problems. We like it. So population P in thousands of Pittsburgh, Pennsylvania from 1990 to 2004 can be modeled by the equation where T is then the year and T equals 0 corresponds with 1990. So basically this is 0 to 14, right? So 1990, 14 years later is 2004. According to the model, what was the population of Pittsburgh, increasing or decreasing from 1990 to 2004? Well, I guess if we plug in 1990, if we plug in a 0 into the equation, right? So we're kind of doing like an XY table maybe for this one. Or we could even graph it. We can graph it. Do you want to graph it? So we could do an XY table. And so we're basically going from 0 to 14. So was it increasing or decreasing from 0 to 14 basically? So we're going to plug a 0 in here, and then we'll plug a 14 in. 0 and then a 14. Okay, here we go. So y equals, I guess you could call it x and p. Yeah, it's fine. So we'll just call this y instead of p. So we're going to plug it into the equation now. So get out your calculator. A lot of these problems are very kind of calculator-based-ish. Okay, so we have a 372.55 second division, so that's E, to the negative 0.01053. Is that right? 0.01053. Cool. Oh, times t. And so times t, or in this case, it's times 0. Okay, we get 372.55, which makes sense. E to the 0 power is just e to the 0 power is just a 1. So that makes sense. And so we get, so y equals e to the 0. Yes, we get 372.55 e to the blah, 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 which is 0 power, which becomes a 1 and goes away. Okay, so we're starting off at 372. What happens when we plug a 14 in now? So we go second enter, brings up the last thing you did, and we'll change our 0 to a 14 now. And we get 321.485. We went down. So we're decreasing. 321.485. 321.485. So we are decreasing. So we are decreasing. Our y value is going down. So as time goes on, our population is decreasing. Let's see here. So basically, yeah, so 372.55 minus 321.485. And so we are decreasing by, how much do we decrease by? Let's see here, so we go 372.55 minus 321.485. So we decreased by 51. Is that 1,000 and thousands? So 51.065. 51.065 thousands. So we decreased from the 14 years, we decreased by 51,000 people. That's crazy. Okay, according to the model, during what year will the population be approximately 300,000? Remember, the equation gives the population in thousands. So 300,000 would actually be P equals 300. And so now we're just going to go ahead and pause me. You try it on your own. So we're going to go ahead and plug in P, 300. So now we have 300 equals 372.55 e to the negative 0.01053. 1053T. And so they want to know, according to the model, during what year will the population be 300 or 300,000, right? So we have to solve for T. Do you know how to do that? Pause me. Try it on your own, please. Pause me. Try it on your own. Since we're decreasing in population, we're going to use red. Oh no, I don't know why, but I'm using red. Okay, let's see. So we're going to go ahead and decrease it. No, that's me, Newbold. Okay, sorry. We'll use that color, I guess. I don't know. Okay, so let's go ahead and solve for T. So we're going to divide by 372. Pause me, try it on your own. Divided by 372.55. Cool. Then we have to undo E. How do we undo E now? So to undo base E is going to ln. So we're going to go ahead and ln both sides. That's going to get rid of the E. So we're going to go ahead and ln all of that. Woo! So we're going to ln all of that. Beautifulness. I'm going to be super exact by just doing the whole thing. Equals. And then this is going to come down now. It's going to come down. So negative 0.01053 and then T. And now I want to solve for T. So how do we solve for T? Mr. T. Cool. Okay, so all we're going to do to solve for T, is divide. So we're going to take that whole thing and divide it by a negative 0.01053. Woo! Get out your calculator. Here we go. So parenthesis ln of 300 divided by 372.55, close parenthesis, divided by negative 0.01053. And we get 20.568. So T is equal to 20.568, right? And so during what year? I guess the 20th year, 20 and a half year. So you'd say between 20. So between 20 and 21 years, basically, right? So between the 20.6 years or 20 and a half year. Woo! Nice. I like it a lot. There we go. Yeah, it looks good. Oh, so they want us to find out which year. Are we not done yet? Oh my goodness. So that's the year, but we have to start in 1990, I guess, don't we? Yeah, the original said start in 1990, Newbold. So 1990 plus 20.6 year, right? So that's going to, we're going to add that approximately 90, 2000, 2010? Yeah, so during the 2010th year, basically, or halfway through that year. So 2010 and 6 months into that about, or 7 months, or whatever you want to say. Cool. All right, thanks for watching. Try them on your own. Try the next one on your own. You got this. Thanks for watching, and bye for now. Bye for now. Thanks for watching. Woo!